All right, where's the focus always located?
Inside the parabola.
Inside the parabola. A parabola does not have a center, it has a vertex. What tells us how wide the parabola is going to be? The lattice. How do we find the lattice? Absolute value of A. How do we find the distance between the vertex and the focus? A equals 4 times P. We know what A is, so we plug A value in for A, we solve for P, and then we graph it, and we're done. Okay? So those are the two things that you need to know. Basically, is A equals 4P. Lattice is the absolute value of A, and then you need to know where the vertex is, where the focus is, and where the lattice is. Alright, so we're going to start out with, guess what? Parabolas who have vertices at the center, at 0, 0, excuse me. 0, 0. So example 6. Example 6. Y squared is equal to 4x. These will already be in standard form. You want your squared term on the left. You want your term that is not squared on the right. Squared term on the left. Squared term that's not squared on the right. So we're going to need to know these things. We're going to need to know our vertex. It's 0, 0 because I have no binomials. Okay, I have no binomials, so the vertex is 0, 0. I'm going to want to set 4p equal to a because I have to know my p value. So that means 4p is equal to 4 and p is equal to 1. You probably start doing that in your head once I go back and review how you find this. So we got to have our vertex. We have to have our p value. We have to know how long the lattice is. You should be able to do that in your head. The lattice is the absolute value of A, and A is 4, and the absolute value of 4 is 4. And then we also have to know one other thing. Which direction is this parabola going to go? Up, down, left, or right? To the right. X is not squared, so your choice is left or right, like the x-axis, and we're going to go to the right. Those are all the things that you need to know. The vertex, the p-value, the lattice, and the direction of the parabola. You're going to go to your graph. You're going to graph your vertex. You're going to travel p units in the direction of your parabola. So since your direction, your parabola goes to the right, then you're going to go 1 unit to the right and graph your focus. So your vertex is going to be at 0, 0. Your focus is going to be at 1, 0. Then you're going to sketch in your lattice, which is not really part of your graph, but it's just going to tell you how wide your parabola is. So since your lattice is 4 units long, then we're going to have to go up 2 and down 2. Up 2 and down 2. And that creates that imaginary lattice that's right here. That's just telling you how far your parabola is going to open up. And then you can sketch your parabola in. So really, when it comes down to it, you're only sketching your parabola through 3 points. The 2 points that are on the outside of your lattice, and then your vertex. Your lattice always goes right through the focus, and your focus is always the midpoint of your lattice. You can just leave it right there, Sydney. Yes, would anybody like to help Sydney walk to the office? I bet Gracie can help you. Hey, Gracie, can you help Sydney carry some things? She's got crutches. All right, bringing back any memories?
Yes.
Okay. All right, number 8. Y squared is equal to negative 12x. Already in standard form, so you should be able to tell me that the vertex is 0, 0. 4p is equal to a, so 4p is equal to negative 12. That means p is equal to negative 3. Our lattice is the absolute value of negative 12, which is positive 12. And since x is not squared and a is negative, the parabola is going to go to the left. So again, we're using the vertex, the p-value, the lattice, and the direction of the parabola to sketch out the parabola. If your p-value is negative, that means you're either going to the left or you're going down based on what variable is not squared. So we'll sketch this out. Again, this textbook likes to do all their graphs that have a vertex or center at the origin first. Since the focus is always inside the parabola, then you're going to travel p units in the direction of your parabola. So we're going to go 3 units to the left, graph our focus. Our lattice is 6, so 12, so half of 12 is 6, so you'll go up 6, you'll go down 6. It's going to be the width of your parabola there, and then you're going to sketch your big fat parabola in.
Fred, I have a question.
Okay.
How do you find the vertex?
The vertex, it'll be just like the center.
Okay.
So if there's parentheses, and you'll change the sign of those numbers, x minus h and y minus k, you'll change the signs. These all have vertices at 0, 0. Same as the center. All right, questions? All right, 14 is almost in standard form. Almost in standard form, but we don't want x squared minus 6y on the same side. So you always want your squared term on the left and your term that is not squared on the right. Squared term on the left, term that is not squared on the right. There are no binomials here. There's no reason to complete the square. That means our vertex is 0, 0. We're going to set 4p equal to 6. This time our p-value is not going to be a whole number. That could happen. 6 divided by 4 is 1.5. Good job. The lattice is the absolute value of 6, so the lattice would be 6. Y is not squared, and A is positive, so the parabola is going to go up. Since the parabola's going up, then you're going to travel up 1.5 units from the vertex to get to your focus. Your lattice is 6 units long total, so you have to go 3 to the left and 3 to the right. Create that imaginary segment called the lattice, and then you'll sketch in your parabola through the 3 points. Questions about 14? Alright, 16 is not in standard form, so I'm going to kind of get you started with this one, and let's see if you can go from there. So 8y squared plus 4x equals 0. How do I know it's a parabola again? Once you start to see all these mixed up, how do I know it's a parabola? Only one squared term. Okay, so what would be the first step to get this in standard form? Yeah. I would move the 4x to the other side, and then you're going to have to do something else, but I'm not going to tell you. See if you can get this one graphed. Okay, it's not in standard form yet. You have to divide by 8. Okay? Your square term has to have a coefficient of a 1. It's not in standard form. That's for every conic section. You cannot have any coefficients of your square terms other than 1 on all 4 conics. So the 8 has to go, and then y'all look at those last 2 examples that we did and figure it out. What might you want to do with this graph that we didn't have to do for the other two? You might want to scale it. Because what did the p-value come out to be? -1/8. So the vertex was 0, 0. The p-value came out to be -1/8. So you had to travel just a little bit to the left. That's probably not completely accurate, but it's okay. And then since the lattice was 1/2, then I had to go up 1/4 and down 4. So this is a 1, so this represents a half. So these little dots right here are supposed to be kind of in the middle of the half. So it's up 1/4 and down 1/4, so that has to be a half unit. All right, 36 and 38 and 42, these are all in standard form. Okay, they're already in standard form, but the vertex is just not at the what? It's not at the origin. So y'all are looking at 36, 38, and 42. Those are already in standard form. How do I know that? The square term is on the left, the coefficient is 1. The variable that's not squared is on the right. So you do 36, 38, and 42. Those are already in standard form. You're going to locate the vertex, the p-value, how long the lattice is, direction of the parabola, and you're going to sketch it out. 36, 38, and 42 are already in standard form. Ask each other for help if you need it. If you can skip steps, skip steps. You know what you're doing. Don't have to write it all down. We're past that. Just be careful if you're skipping steps. Just make sure you go back and do a little quick check.
Like to the other side of the room.
So when we go to you, do we need to? There's a number over here. And that's also this parentheses.
Clean that image or whatever.
It'll be a parentheses. So this one's in standard form.
Come in point blank.
If it's a plus or minus a number. Oh, okay, so if there is, you have to pull it out. Okay.
First round, you wouldn't have a lot.
All right, any questions about 36, 38, or 42? Using your people. Paul, what team are you on? We them boys? Is that your team? Y'all in first place, I saw. Alright, everybody get off 36, 38, and 42. Are y'all gonna realize if you see one of those are already in standard form? Hopefully. Alright, so 44 and 46 would be parabolas that were not in standard form. So let's do one together and then you do one on your own. Let's look at 44. So again, you're going to know that you're not in standard form because you have an x squared but you don't have a y squared. So parabolas only have one squared term, either the x squared or the y squared. So that's what's going to identify what you have. Then what you're going to do is you're going to know that the squared term has to be on the left and the term that is not squared and any constant has to be on the right hand side. So that means in your first step you're going to leave x squared and 6x on the left, move the variable that's not squared and any constant term over to the right hand side. If you change sides, you change signs. So make sure you change the signs of those two terms. Then you're going to decide whether you have to complete the square. That's only going to happen on the left-hand side because that's the only place you're going to have an x squared or a y squared. Am I going to have to complete the square if I have an x squared and a 6x? Yes. Okay, so half of 6 is 3 and 3 squared is 9. If you add 9 on the left and you have to add 9 on the right, then you have a perfect square trinomial that will factor into a binomial squared. So your binomial is important. It's going to tell you where the vertex of your parabola is. On the left hand side you're going to combine the -1 and the 9. And here's the part that a lot of people forget. If you have a number being added or subtracted to your variable that is not squared, then you have an extra step. And that extra step is to factor out whatever is in front of your variable. So you'll have to factor out a -8. So -8 times y is -8y, and -8 times -1 is +8. So you'll have to factor out, if you have a variable plus a number or a variable minus a number on the right hand side, you'll have to factor the number out that is the coefficient of your variable. Then your equation will be in standard form. Any questions about that process? So what happens here is we can do parabolas on parabola day, we can do hyperbolas on hyperbola day, and we can do circles on circles day, and ellipses on ellipsis day, and then we throw them all together tomorrow. That's where it starts to get a little bit confusing. But you've seen this, some of you. This is the second time, so hopefully all that's going to make you feel a little bit better. Vertex of this parabola is -3, +1. Let's see if we can do the p-value in our head. 4p equals -8, so p equals -2. The lattice is 8, and you don't even have to write this down if you know what you're doing. And what else do I need to know? Up, down, left, or right? Down. And then you'll sketch that one out. Probably one of the most common mistakes is that people forget to cut that lattice in half, and they end up making the lattice twice as long as it's supposed to be. But remember, it's got to be a total of 8 units, so you've got to move 4 and 4 to get 8. Questions about 44? You try 46 on your own. If you're not already there, try 46 on your own. Alright, what y'all get for the vertex of 46? 0, 1, p-value, 2, length of the lattice, direction of the opening to the right. Alright, because the 1's canceled out there, you didn't have a parentheses on the right hand side because you were not adding or subtracting a number.